Okay, so the title is 4-4 in your book, Composition of Functions. On your worksheet for inverses, you did a little bit of composition of functions. To tell us at the bottom of your worksheet for homework, let's do next time, to tell if two functions are inverses of each other, didn't we plug in g of x, we plug in one function inside the other, so f of g, if it equals x, that's good news that it's probably an inverse. And then you have to reverse it and plug in g of f of x. If that one also equals x, then you get that they're inverses of both inverses of each other. So you had a little bit of that on your worksheet. And then today we're going to add in add, subtract, multiply, and divide. So at the beginning we have two given functions. For example 1, I want us to find what f plus g of x is. Order is very important. We have our f is given and our g is given. Which one has it been asked to use first? Order is important. F. So we just write f first. 144x minus 48. After f, we're going to add g. So what was g? 12. So we're just going to add 12. That makes sense, right? We have the f, and we add the g. So I notice here we have two like terms. These are both in the integer family. This guy is in the x family. He doesn't have any like terms. So f plus g of x equals 144x. What do we get here? Negative 48 plus 12. That would be positive 48 plus 12. Negative 48 plus 12. Negative 36. So a way to do this is I break it up sometimes in place values. We have a 10 and we have a 2. Negative 48 plus 10 is negative 38, because when you're adding, you're going to the right on the number line. You're going to get closer to 0. And then add 2 more, it'll be negative 36. Yep. Okay, I want to practice saying these compositions. This is f plus g of x. So will everyone say that, please? F plus g of x. Bella, say it, please. Thank you. Colby? How do we read this? Of x. Thank you. So this x is not a multiplier. It's evaluating an x. It's not a multiplier. Okay, let's try another one. Example 2. We're still using those green functions at the top. We're going to do f minus g of x. F minus g of x. Order is important. Technically, with addition, you can add in any order and you'd be fine, because we have this thing called the commutative property of addition and the commutative property of multiplication, and you can add in any order and get the same answer. But subtraction doesn't work that way. So just make it a habit to always do it in the order written. Dominique, what's the first function we need to write down? Which function's written first? Inside the parentheses here, is it f or is it g that's written first? F. And so up above in green, what's the f function? It's right here after the equal sign. What does it say? Keep going. The x is just a variable. Yep. So let's write that down. 144x minus 48. Okay? Now we're going to be subtracting. Now careful when you're subtracting. You have to make sure you subtract everything. G comes second, right? So we're subtracting everything that's in G, which in this case is only a 12. But in case there's multiple things, put it all in parentheses. Okay, do we have like terms? We have the integers again, same type of things. Negative 48 minus 12. Okay, Marianne, what is negative 48 minus 12? I'm sorry, Marianne? Yep. Negative 60. Yep. The negatives, just to give you a visual, here's 0. Here's negative 48. When we subtract, we keep going this way. Versus the first one we did, when we add, we go this way, closer to 0 when we add. Okay, so yeah, negative 60. So our answer, I would appreciate if every time you rewrite f minus g of x equals, and write this in standard form. The highest exponent is 144x, so that's x to the first power. This constant minus 60 is actually x to the 0 power. That's why there's no x's written. Okay? Any questions? It's not too bad, right? Now we're going to do multiplication. I'm going to throw one new thing on. F times g of 2. Would you say this, please? F times g of 2. This means evaluated at 2. Because I'm adding an extra step. This was just evaluated at x. But now we're going to evaluate a specific x, which is 2. So let me write these over here so I can see both of them. F of x was 144x minus 48. G of x was 12. Okay. Okay, f times g evaluated at 2, or of 2. We're just going to ignore the 2, and this was on the last video when you were finding, are they inverses of each other? We're just going to ignore the 2, and just first do f times g. When you're timesing, though, you have to take everything. The f function, Stetson, what's the f function? Yep. 144x minus 48. That has 2 pieces to it. So you either need to put it in parentheses or brackets, some form of grouping. All of that is going to be times by all of g. Okay? Maria, what is g? 12. Great. Can you give me a motion of some form that tells me how I multiply these? How would I multiply these? It's the, what's that property? Distributive property. Get the arrows popping. But you should always distribute to the left first. So I'm going to take that 12, and I'm going to distribute to the left first. If you need a calculator, come grab one. 144 times 12, I don't even know what that is. I know 144 times 10. Okay, if you need calculators, there's plenty of calculators up here. New people, we have calculators up here at the front. Come grab a calculator. We have yellow ones, and we have some black ones. The yellow ones are newer, the black ones are kind of older. Do you have the answer? Okay, hold on just a sec. Okay, Brianna, what'd you get for the product of 144x times 12? And then after the 8 comes in x. Yeah. Okay. We have one more to do. Is it 12 times 48? It's negative 48. Do 12 times negative 48, please. Kaylee, do you have 12 times negative 48? Negative 576. And this is in standard form because we have x to the first power, and then we have x to the 0 power, so they should be descending in power. Now that is just f times g of x. But we wanted to find f times g of 2. So any idea what to do with the 2 now? Well, kind of times. Why do we times by 2? Not everything's doubled. Only one part will be doubled. Chris? It's a plug-in. It's evaluate. So we're going to plug it in where the 2 was, or where the x was. Put parentheses, because we're going to multiply only that first one by 2. The second one doesn't have an x. Okay, type all that in. Stand up when you have the answer of f times g of 2. Stand up when you have the answer of f times g of 2. Just plug it in. Stand up when you have the answer. Yeah. It's gone right now, and he's been gone a long time, so we don't have one. Okay, Colby, do you have the answer? Maria? All you have to do is type that in your calculator. Omar? What'd you get, Omar? Type it in, please. Okay, it was, your last name starts with a C, so now I'm confusing myself. What's your, Kenny? Kenneth? Kenneth, what'd you get? Everyone have a seat. 2,880, that works. And with your answer 2,880, I want you to write f times g of 2 equals 2,880. Okay? Did you not get 2,880? Okay. So when we have an x, you just do whatever operation it says. But if it's evaluated at a different number, at the end you have to plug in that number. Okay? Let's finish this first. He already sat through the lesson yesterday. Let's do one more where we're using these same functions, f and g. We've done add, we've done subtract, we've done multiply. Any guess what I'm going to do now? Divide. Now order is important. F divided by g evaluated at 3. So that's called the quotient of f and g of 3. So this 3 is not a multiplier. It's of 3. It's being evaluated at 3. So first, oops, we're not down there yet. First, do f of g, f divided by g of x. Okay? I want you to do that by yourself. I want you to have f divided by g of x, then plug in the 3. Try it out. Make sure you're doing it in the same order that it's been written. Whatever function's in the numerator should be the function you write in the numerator. If you're in this class, we're actually doing a different assignment. Okay. It's not in the book. We're going to get to it in like a couple minutes. So the 3 goes wherever there's an x. It replaces the x. In that case, it's, yeah, multiplied. Now you have to divide everything. So can I borrow your pencil? So on this line, I would scoot that down a line. And I would not divide like that. I would divide like this. Or individually. because it's probably easier to see it individually. Everything's divided by 12.
Okay.
Okay, yep, good so far. I'll simplify it.
Yeah.
Make sure it's simplified. Yep. Yep. Okay, let's see. Tyson, will you pick someone to come write their work on the board? Whatever. Stetson, you're up. Come show your work on the board, please. Sure, you can bring that up if you want it. Right here next to the bottom one. Okay, step to the side. Let's take a look. What do you guys think? Thumbs up?
Yeah.
Middle, we need to adjust something, or thumbs down? What do you think? Thumbs up. Middle, we need to adjust something. Thumbs down. I think it looks good. Because F, keep it on top, right? Because it said F. This is the F function, and it's on top, correct? And G was 12, and you put 12 on the bottom, right?
Yeah.
Okay. Now simplify it, please. Without plugging in the 3. We're not plugging in the 3 yet. Just come out here to the right side and simplify it over here.
I didn't do that on here.
144x divided by 12, because both of them have to be divided by 12 individually. Okay, what do you guys think? Is that actually 12x minus 4? Is 144 divided by 12, 12? Yeah, that's a perfect square. Negative 48 divided by 12, is that negative 4? Yeah. Okay, Stetson, I'll let you pick someone to come do the last step, which is evaluating at 3. Okay, so, oh, you can do it. Just come up to the board and do it for us. Evaluating at 3. So you're just going to write all of this. I'll write the setup for you. Oops, I thought it copied and paste. Paste, paste. Doesn't want to paste. Hold on. Copy, paste. Maybe it's pasting like some foreign place I can't find. Anyway, rewrite this right here because it's not working for me. Yeah, here, I'll move it down a little bit for you. Okay, is that what you're supposed to do? You replace the x with 3? Yeah, okay? So, multiply or subtract first. Which do we do? Multiply. 12 times 3. What do you think? Yep. Okay. All right. Good. And if we could also on the end of it put equals f of over g evaluated at 3, that would be awesome. But yes, 32. One more, Colby, and then I'll let you go to the bathroom. Or drink, whatever it was. Okay? One last problem, but I'm going to change it up. Different functions. H is 3x minus 5, and b is 6. Okay? We're going to do b minus h of 5. Okay, Try that on your own, please. Raise your hand when you think you have the correct answer, and I'll come check.
I got it.
And make sure your answer is written in standard form. And then evaluate. Ooh, close. But you made an error. That is correct. Raise your hand when you think you have it. A curveball. Make sure with subtraction you subtract everything, not just the first term, everything in that function. Yes, good. If you're getting negative 14, you've made an error on the first step. Can you go back to your seat, please?
Okay.
We're not timesing. We are doing b minus h, and you do that first, and then evaluate at 5. No, because you don't, it's not times 5, it's of 5. Which means we're evaluating at 5. But you don't plug in the 5 until the very, very end. For your notes. Where's Isaiah Cooper? Can I see your notes, Isaiah? No. Okay, I guess I need to show you the first step, because lots of people are making the same mistake. Now this one I changed the order. I didn't do h, which was written first, and then b. I did b minus h. So what's the b function? 6. Then we subtract everything from h. What is h? 3x minus 5. You don't put parentheses. You're not subtracting everything. Yeah? Yeah, I'm subtracting the whole h function. Well, there are some like terms. There's constants that are like terms. We have a negative here. When we have a negative, it's really a negative 1 being times in. It changes the sign of everything. If we're subtracting a 3x, it becomes negative 3x. And if we're subtracting a negative 5, it becomes a positive 5. And these two are like terms. 5 plus 6 is 11, but I'm going to put it in standard form. The x term first, make sure you realize it's a negative 3, and the constant second. That is b minus h of x. Okay, You have to put, especially when you're doing subtraction, you have to put that in parentheses or you're going to have some errors. But we're not done. What's the last thing we need to do? Plug in the 5. Isaiah Cooper, where did I plug in the 5? Okay. So it becomes this. Negative 35 plus 11. I plugged in the 5 for x. Is that what it becomes? What's between the negative 3 and the x? Multiplication. So when you plug in, you should put parentheses. So we get negative 15 plus 11, which is negative 4. If you were getting negative 4, you have the right answer. If you didn't get a negative 4, did you find where your mistake was? Do I have any questions? You'll be back in 3 minutes. Okay, I'm going to give you, I think it's 4 problems where you try these out, and they are due today. And then the remaining time will be yours to work on your inverse functions homework worksheet. Okay, so get a new piece of paper because the notes are going to be turned in when we have our first test. A new piece of paper. Entitle it 4-4 Composition of Functions. Okay, some of them, the first 2, have to do with f and g, which are up here in red. But then 3 and 4 have different functions. Numbers 1 and 2 are functions of x. But numbers 3 and 4, you're evaluating that number. So 3 and 4 have that extra step, where the very last step is you plug in a 2 or a 3. You can work with the neighbor sitting by you if you are working, but this is due at the end of class. No exceptions. So you have to turn it in at the end of class, yeah? Of the what? 4-4 Composition of Functions. Oh, the homework, the one for tonight? Oh, I thought you meant the video I'm recording right now. It's solving 2 variable and systems of inequalities.